All right, for homework number 28, first problem is just find the indefinite integral. So we're going to let u equal x plus 1. Du dx would equal 1. Now, when this is the case, when the derivative of u is just equal to 1, you don't really need u sub. You can put it in if you want, but there's no adjustment that I would need to make. It would just be the integral of 1 over u du. I don't need to, du is equal to dx, so there's not really anything to do there. So there's not really any u sub needed. And so I can just say, okay, what is the derivative, or what is the integral of 1 over something? So it's the natural log of the absolute value of x plus 1 plus c, because this is an indefinite integral. All right, so that's it for the first one. For the second one, we're going to let u equal 9 minus x squared. Du dx would be negative 2x. You can solve this for du. Solve this for dx. And then we can make our substitution here. So we have x on top. This is now the square root of u. And instead of dx, we're putting in du over negative 2x. So the x's cancel. I'm going to rewrite this a little bit. I can take a negative 1/2 out in front. Times the integral of, instead of 1 over radical u, I'm going to make it u to the negative 1/2 so that I correctly apply my power rule for integrals here. And then I can integrate. So add 1 to this exponent, you get u to the 1/2, and you divide by that new exponent, plus c, and then I'll clean this up. So instead of u to the 1/2 divided by 1/2, that's really 2 times u to the 1/2, and 2 times negative 1/2 is just negative 1. U was 9 minus x squared. It's to the 1/2 power plus c. You can rewrite that as negative square root of 9 minus x squared if you want. Quick reminder, quick reminder, you're not allowed to square root individual terms, so this definitely is not allowed to be like 3 minus x or anything like that. Okay, for the next one, I see that u could be, it's usually going to be the denominator. It's definitely going to be the higher degree thing. So let's see. Let's let u equal x cubed plus 3x squared plus 9x. And then du dx will equal 3x squared plus 6x plus 9. Now I have x squared plus 2x plus 3, but take a look at this. You can, we can still solve this for dx, but let's factor a 3 out. So the 3 is still there, but if you factor a 3 out, that's your x squared plus 2x plus 3. So we are going to get that entire expression to cancel, so that's good. So we have the integral of, I'll just write it out, x squared plus 2x plus 3 over, this bottom part was u. Instead of dx, we have du over 3 times x squared plus 2x plus 3. So those will cancel. Let's bring the 1/3, the 3 in the denominator, let's make that a 1/3 on the outside. And now it's just 1 over u du. So the integral of 1 over u is ln of absolute value of u. So 1/3 ln absolute value of x cubed plus 3x squared plus 9x plus c. And we'll leave it like that. For number 22, now we have the natural log of x to the third. So you don't want to just make u x to the third because that's not going to work. But what if we make u equal to the natural log of x to the third? And remember, we had this in homework number 27 where we can make this, 1 over x to the third when we take the derivative. 1 over x to the third times 3x squared. Or remember, you can expand natural logs. So take the exponent and move it down in front. This makes the derivative a little bit easier to get to the simplified version. So du dx will just equal 3 over x. That way I don't have to cancel things and risk making an algebraic mistake. All right, so so du will be getting multiplied by x over 3 to equal dx. So let's see where that gets us. That gets us to 1 over x, and then we have natural log of x to the third. That was u. And then dx is now x times du over 3. So see how the x's are going to cancel there. There's a 1/3 out in front, just like the last one. And this is back to integral of 1 over u du. So it's 1/3 natural log of the absolute value of the natural log of x to the third. That's weird, right? Plus c. It's okay to have natural logs within natural logs. That kind of happens quite often, actually. All right, what about this problem? This one's a little bit strange. When I first saw this, I thought, oh, well, if I distribute the x, I would get x squared minus 2x. And if I expand this out to its like polynomial form or its general form, maybe things will work out, but they didn't. So this is one of those where maybe we do this. U is equal to just x minus 1. I know that doesn't get us very far, but remember we had this trick back in chapter 4 too, where if we had all these expressions and x's weren't really canceling, maybe we just rework this u equation. Like, okay, so if I replaced x minus 1 to the third, so in the denominator I have u to the third, but what about if I just have an x here? I can solve this equation for x. X is equal to u plus 1. So now in place of that x, I can put in u plus 1. And then what about x minus 2? So if u is equal to x minus 1, then I can subtract 1 from each side. And u minus 1 is equal to x minus 2, right? X minus 1 minus 1. So this could be u minus 1. And then what's dx? So go back here. If u equals x minus 1, then du dx equals 1. So du equals dx. So I can just put in du. So we did use u sub, but it wasn't to get things to cancel. It was to rework it to replace everything. So now what do we do with this? Well, let's go ahead. I want to use Hart method. I want to divide by u to the third, but first I've got to FOIL this together. So make this u squared minus 1 over u to the third times du. Now remember, I can divide a binomial by a monomial. That's what I mean by Hart method. In pre-calc, we said this looked like a heart. So now it's the integral, the integral of 1 over u minus the integral of 1 over u to the third. So maybe I'll just make that minus u to the negative third du. Now the integral of 1 over u is natural log of the absolute value of u, which was x minus 1, minus add 1 to this exponent, you get u to the negative 2 divided by that new exponent. Okay, and then I want to clean that up a bit more. Oops. So natural log of x minus 1 minus negative will be plus. Let's bring this negative exponent down to the bottom. So there's a 2 down there, and u was x minus 1, and then plus c. All right, more indefinite integrals. Now this one, so when I started this, I was thinking like, oh, I can make this 1 over sine or try u sub, however. But if you make it 1 over sine, you have to do a lot of like trig magic with identities to get this to work. But then I remembered, oh yeah, we have this one in our notes. And I'm going to be honest with you, this integral of cosecant or secant or cotangent, any of those weird ones that were in our notes from yesterday, any of these. Yes, we have sine and cosine and tangent and cotangent because you can rewrite tangent and cotangent in terms of sine and cosine and get these to work out. But these two, I do not have memorized. I don't think that we're going to be given that. We could work to memorize it. But anyway, I just wanted to preface what I'm about to do, which is saying, okay, just use your notes and you get this done pretty quickly. And then I'll explain what all this craziness is over here. So, all right. So First off, it is u sub because remember, when the expression inside of a function does not have a derivative of 1, u sub is necessary. There's going to be some adjustment that needs to be made because du dx is 2. So dx is going to be du divided by 2. So I do need to say, okay, this is cosecant of u, and then instead of dx, it's du over 2. So I'm going to put the 1/2 out there. And this is where I was kind of like starting to try to do some trig stuff, but then I remembered, oh, okay, according to my notes, the cosecant of u is equal to this. So we have a 1/2. There's a negative out in front, so negative 1/2 natural log of the absolute value of cosecant of u, which is 2x, plus cotangent of u, which is 2x, plus c. On a quiz or test for me, for this class, I will not give you cosecant or secant under the integral because, again, if I don't have this memorized, I'm not really expecting you to memorize it. But as I was doing this, I was kind of curious, like, wait a minute, why is this the case? Like, can I work on this to try to prove it? And I could not figure out how to get from 1 over sine to something that represented this. But then I remembered, well, I should be able to take the derivative of an antiderivative and get the integrand, right? So I worked on this a little bit. So I took this negative and applied it. Cosecant u plus cotangent u to the -1 is 1 over that expression. And then I thought, well, these have a common denominator, 1 over 1 plus cosine over sine. So I haven't done any derivatives yet. I'm just working on this expression. 1 over that fraction is just the reciprocal of that fraction. Okay, and then I expanded this into subtraction. So now I feel like I'm kind of getting somewhere. Okay, so I've expanded. Once you expand, you can say, all right, let's take the derivative with respect to u of both sides. So this is 1 over sine times cosine. This is 1 over 1 plus cosine times chain rule, negative sine. The plus c should not be there anymore. That should be 0. I think I meant to write plus 0 there. And then I did a common denominator. So I multiplied this fraction by 1 plus cosine and this fraction by sine. And then I distributed the cosine through. Cosine squared plus sine squared is the Pythagorean identity that's equal to 1. And then 1 plus cosine cancels with 1 plus cosine. 1 over sine is cosecant. And yay, got that done. So what would you have to do to go from the integral of cosecant to get to this? I think you'd have to work backwards. I think you'd have to be like, oh, it's 1 over sine. And then you'd have to think, oh, I know, I'll multiply in a 1 plus cosine over 1 plus cosine. And so anyway, you can see how things could get kind of tricky, but you would basically just go back a step. And I don't think that I would have ever figured out to do this step right here on my own. So anyway. All right. What about number 37? So let's let the denominator, if you're not sure between trig, remember you're letting the denominator usually equal your u. So I'm going to let u equal 1 plus sine of t. And then I'm going to du dt to get cosine t. So du divided by cosine t is equal to dt. So we can set this up as cosine t over u times du over cosine t. Those cancel. So it's just the integral of 1 over u du. So this is natural log absolute value of 1 plus sine t plus c. Now 1 plus sine t doesn't actually need an absolute value around it because remember the original sine graph ranges from 1 to -1. So if you plus 1, if you shift it up 1, then that sine graph is now going to look like, okay, this is a bad sketch, but the sine graph is now going to look like, here we go, this. It'll never hit 0. So you might see in multiple choice, they don't have the absolute value around it. And that's just because whatever expression they wrote down must be always positive. All right, evaluate the definite integral, use a graphing utility to verify. So I left my graphing stuff up here. And we'll just see where we go from there. So, all right, we want to use our u sub on this. Now, normally we let the denominator equal u, but on this one, wherever the natural log is, that's going to be your value for u. Because remember, the derivative of natural log is 1 over x. So it's really the x in the denominator that I'm going to be canceling out. So let's let u equal 1 plus ln x. And du dx is equal to 1 over x. And so multiply x over times du. That's going to give us dx. All right, so now it's the integral from 1 to e. I'm not going to bother changing my bounds of u squared over x. And then dx is x times du. So the x's do cancel. So integrate u squared, you get u to the third over 3. But u is 1 plus ln x to the third over 3. Now we have to remember how to work with natural logs. So 1 plus ln e to the third over 3 minus 1 plus ln 1 to the third over 3. You could also have factored a 1/3 out. Natural log of e is 1 because remember that's saying e to what power is e. So 1 plus 1 to the third is 8/3. Natural log of 1 is 0 because that's saying e to what power is 1. So 1 to the third is 1/3. So my answer here is negative 7/3. I checked this on my calculator. When you're checking on your calculator, see how I just did the integral from 1 to e and put in the exact expression up here. So you're not doing any sort of u sub work on your calculator. So I got this answer. I checked. That's 7/3. Oh, wait, I got negative. Oops. But 8/3 minus 1/3 is definitely positive 7/3. All right. For the next one, so again, I have trig, both like degree 1 type things. So use default to the denominator. Let u equal theta minus sine theta. Du d theta will equal 1 minus cosine theta, which we have up there. If you don't, by the way, if you're getting to a place where you don't have to keep solving for d theta or dx or whatever, like if you don't have to do this step, if you can see what's going to cancel, that is perfectly fine. I would actually like you to get to a place like that. But if you can't, it doesn't take long to just, or if you're nervous to do that, it does not take long to just go through the proper steps here to say, this is what we're doing every time. Oops. All right, so I've got 1 minus cosine on top. I've got u on the bottom. D theta is du over 1 minus cosine. So boop, boop. So the integral from 1 to 2 of 1 over u du. So this is the natural log of theta minus sine theta from 1 to 2. So I didn't change my bounds here. I'm just going to do the math here. So this is where so here's my answer. Natural log of the absolute value of 2 minus sine of 2. And remember, that's like sine of 2 radians. Minus the natural log of the absolute value of 1 minus sine 1. I almost wrote plus c. No plus c. So this is the answer. When I checked this in my calculator, when I did that with the absolute values in there, oh, wait. Maybe I just found it. Is it because I didn't have a parentheses here? I bet that's it. When I did that, I was like, I could not see why I was getting a different number here. But when I did the integral, I got this number. When I did this work without the absolute value, but now I can see I closed parentheses there. I did that. So actually, let me do this. Let me just do this because that was really driving me crazy. And I couldn't understand. You don't really need the absolute value because 2 minus sine of 2 is positive and 1 minus sine of 1 is also positive. So that's why I didn't really need the absolute value, but I couldn't understand why it would have been making a difference. But I bet this is it. So I closed around the angle, but see how I didn't close here? I didn't put another parentheses. So I think the calculator thought I was still with putting natural logs within natural logs. Let's see if I can remedy this situation because that was really driving me crazy the other day. So 1 minus sine 1. Close that. End that. Close that. Yes. Okay, that was it. All right, so I'm going to change this. Missed a parentheses. Oh, it's too early for me to think about spelling parentheses, so I'm just going to do that. All right. Okay, problem solved. That makes me feel better. All right, what about this? Little second fundamental theorem of calculus here. Find f prime of x. Remember, when f of x is equal to the integral from whatever constant to some function up here, whether it's x or x squared or 3x or whatever, I'm just going to say f of t dt. What do you get from that? Not equals. What do you get for f prime? When you take the derivative of the integral, yes, the integral cancels out, and you get this function with the g of x plugged in, multiplied by g prime of x. That's important. It's not going to matter for these two because g prime of x is 1. But if this is anything other than x, you do have to consider that. So I want you to get in this habit of like writing this out. All right, so f prime of x. And the proof for why that's the case, by the way, is there's like a short little proof in our notes for that back in chapter 4. All right, so f prime of x will be 1 over x, technically times 1. So f prime of x is just equal to 1 over x. Not very exciting for that one. Excuse me. Same thing here. F prime of x will just equal tangent of x, technically times 1. So just tangent x. All right. Find the area of the given region. It's really hard to see this, but there's like a little pink shading between 1 and 3. So, and then use a graphing utility. So I left my work up here to verify what I got. So we want to set up the integral from 1 to 3 of 6 over x dx. There's no u sub needed here because u would just equal x. So this could be 6 times, and you can put the 6 on the outside if you want, natural log of the absolute value of x, and we're evaluating from 1 to 3. So this is equal to 6 natural log of 3 minus 6 natural log of 1. What is natural log of 1? You're expected to know that. That's 0. Natural log or log any base of 1 is always 0. So this is really just 6 natural log of 3. I checked on the calculator when I did the integral. I got this. 6 natural log of 3 is also equal to that. So that's verified. For number 82, it says use the trapezoidal rule, and we're not going to do Simpson's rule. Honestly, I don't know what Simpson's rule is. I'd have to look it up. It's not on our AP exam. To approximate the value of the definite integral, let n equal 4, and round your answer to 4 decimal places. Use a graphing utility to verify. So, oops, I don't think I did that. So, all right. Remember, if we're doing a Riemann sum, we sketch the little graph. It's a good idea to do that. It's not required, but I think it's nice to do that. So if I plug in 0, I get 0. And then we're going up to 4. Plug in 4, you get 32 over 16 plus 4, so whatever, something up here. You get 32 over 20, I guess. I am going to use my calculator for the Riemann sum anyway. We are getting a delta x from 4 to 0 divided into 4 parts. So delta x is just 1. So divvy that up. And then remember, you're doing trapezoids. So the area of a trapezoid, when we're talking about these little within our function, it's 1/2 times the height. Well, the height is delta x times the sum of the bases. And the sum of the bases will be like f of a plus f of b. And then the next one will be like f of b plus f of c plus f of d, until you get all the way to the end. So you're going to get all of these little doubles up here. All right, so this is approximately equal to 1/2. Delta x was 1. And then we're going to start summing the bases. So the first trapezoid is f of 0 plus f of 1. And then the second trapezoid is going to be f of 1 plus f of 2. So I'm just going to put a 2 in front of the f of 1. There's 2 of those. And then same thing with f of 2. You're going to get, after this one, then we're going to get f of 2 again plus f of 3. So there's 2 of those. Same thing here. You're going to get f of 3 again plus f of 4. f of 0 does not get used twice. F of 4 does not get used twice because those were only in one trapezoid. And then let's use our calculator for this. So because I don't want to keep typing in 8x over whatever squared plus 4, let's just type into the y equals. So alpha y equals, I'm going to make mine a fraction so I don't have to think too hard about parentheses like this. Okay, and then it's 1/2 times y1 of 0 plus 2 y1 of 1 plus 2 y1 of 2 plus 2 y1 of 3 plus y1 of 4. We got 6.246153 blah blah blah. So okay. And we can change that to a fraction if we wanted to. 406 over 65. That's a decimal. That was 6.246. That's our approximation here. And then use your graphing utility to verify. So when I do this actual integral, I might not get, or I shouldn't really get the exact same thing, because remember, the trapezoidal sum is just an approximation. I don't know why I'm typing it again. I could just put y1 in here, but that's okay. Okay, so see, it's pretty close. It's a little bit higher. Again, it's not going to be the exact same thing because trapezoidal will leave some area out or sometimes overestimate depending on the function. For 97, find the average value of the function over the given interval. So f average, the given interval here, it's right here. It's 2 to 4. I was going to say this is a hard, it's difficult to see the pink shading there. So f average is equal to 1 over 4 minus 2 times the integral from 2 to 4 of f of x dx. So let's clean this up a bit. This is 1/2. I'm going to pull the 8 out. So 1/2 times 8 is 4 times the integral from 2 to 4 of, instead of 1 over x squared, I'm going to make it x to the negative 2. I rewrite negative exponents anytime it's not just 1 over x, because I don't want to accidentally write a natural log for something. So this is going to be 4 times, when you add 1 to this exponent, you get x to the negative 1 over negative 1. We can factor this negative 1 out if we want to. You don't have to, but that would just make it negative 4. And then I'm going to go back to this is 1 over x. I do always, even though I rewrite the negative exponents to integrate, when I'm done doing that, it's a good idea to always rewrite this so that you don't accidentally put like 4 minus 2 instead of 1/4 minus 1/2. So this is negative 4. And like I just said, this will be 1/4 minus 1/2. 1/4 minus 2/4 is negative 1/4. Average value of 1. Remember, average value means like, so here are your y values. They range from, I guess, 2 to what, 1/2. So it makes sense that the average value 1 is sort of like it's not always going to be the exact middle, but it's sort of like the average somewhere near the center height for that value. Okay, a population of bacteria is changing at a rate of this, where t is the time in days. The initial population when t is 0 is 1,000. So p of 0 equals 1,000 bacteria. Write an equation that gives the population at any time t, and find the population when t is 3 days. So we want a p of t equation, and then we want p of 3. All right, so this is an integrate, separate, celebrate type deal going on. So let's make it dp equals 3,000 over 1 plus 0.25 t dt. So I multiply dt over here. Then I'm set up to integrate both sides. The integral of dp is p. Let's work on this a little bit. So we can pull the 3,000 out front. Okay. And then I'm going to show my u sub over here. Let's let u equal 1 plus 0.25 is just like 1. Oops. It's just like 1/4 t. So then du dt will equal 1/4, which means 4 du will equal dt. All right, so I pulled the 3,000 out. I've got 1 over u, and dt is 4 du. So I'm going to put the 4 out there too. So I've got this out to 12,000 over, or times the integral of 1 over u du. So that's 12,000 times the natural log of the absolute value of 1 plus 1/4 t. Oops, I was setting up a definite integral, wasn't I? Plus c. Okay, so we have this so far. We know that the bacteria, there's 1,000 bacteria when t is equal to 0. So this is 12,000 natural log of just 1 plus c. Natural log of 1 is 0, so c is 1,000. So asking for the formula for p of t, it's 12,000 natural log of 1 plus, I'm going to write this as 0.25 t. It just looked weird the way I was writing it there. That should be an absolute value. Instead of plus c, it's plus 1,000. And then also find p of 3. So I can do that on the calculator here. So 12,000 natural log of 1 plus 0.25 times 3. Close that, plus 1,000. So 7715.389. And the label on that is bacteria. I'm not sure if we should round in the nearest bacteria or not, so I'm just going to leave it to 3 places. All right, last problem. The demand equation for a product is P equals 90,000 over 400 plus 3x. Find the average price P, so P is the price. So find P average over the interval 40 to 50. So that's going to be 1 over 50 minus 40, so 1/10, times the integral from 40 to 50 of 90,000 over 400 plus 3x dx. All right, so let's work on this a bit. We can take the 90,000 out in front, and 90,000 divided by 10 is now 9,000. We need a little u sub here, so u is going to equal 400 plus 3x. Du dx is going to equal 3. Plug my pen back in real quick. Du dx is going to equal 3. So du divided by 3 is going to equal dx. So we have 1 over u, and then dx will be du divided by 3. So let's take the divided by 3 and put it out here. So now it's 3,000 times the integral from 40 to 50 of just 1 over u du. So now we can integrate. This is 3,000 times natural log of the absolute value of 400 plus 3x. Sorry, definite integral. And we're going from 40 to 50. So that's 3,000 times the natural log of 400 plus 3 times 50. So 400 plus 150 is 550 minus 3,000 times the natural log of 400 plus 120 is 520. So that's our average. I'm not going to plug that into the calculator, but I could. That would be the average price over that integral. All right, that finishes this homework assignment. Please come into office hours if you're struggling with any of this or if you want more practice.